Sand, it's everywhere. It's in the deserts that stretch for miles, the beaches where we relax, and even in the playgrounds where children laugh and play. This ubiquitous material is so common that we often overlook its significance. We walk on it at the beach, feeling its grains between our toes, build sandcastles with it as children, creating memories that last a lifetime, and may even have a jar of colorful sand from a vacation souvenir shop, a small keepsake of a cherished trip. But how often do we really think about this seemingly mundane material? How often do we ponder its journey from the earth to our hands? The truth is, sand is an unsung hero of our modern world. It's a silent partner in the construction of our cities and the infrastructure that supports our daily lives. It's the silent ingredient in concrete, glass, asphalt, and countless other products that shape our daily lives. Without sand, the very fabric of our built environment would crumble. From the towering skyscrapers that define our city skylines to the smooth roads that connect us, sand is the foundation upon which much of our civilization is built. It's in the glass windows that let in light, the concrete walls that provide shelter, and the asphalt roads that facilitate our journeys. We often take for granted the availability of sand, assuming it's an infinite resource. We see it as an endless supply, always there when we need it. However, the reality is far more complex. The extraction of sand has significant environmental impacts, and the demand for this resource is growing at an alarming rate. The global demand for sand has skyrocketed in recent decades, fueled by rapid urbanization and infrastructure development, particularly in developing nations experiencing booming populations and economic growth. This surge in demand has led to a race to extract sand from rivers, beaches, and the ocean floor. This surge in demand has put immense pressure on natural sand resources, leading to a hidden crisis that often goes unnoticed until it's too late. The environmental consequences are severe, with landscapes being scarred and ecosystems disrupted. The consequences of this sand shortage are far-reaching, impacting not only the construction industry but also the fragile ecosystems from which sand is extracted. Shrinking beaches and disappearing islands are just the tip of the iceberg. From shrinking beaches and disappearing islands to the destruction of aquatic habitats and the livelihoods they support, the environmental toll of sand mining is a stark reminder of our interconnectedness with the natural world. Local communities are often the first to feel the impact, as their homes and livelihoods are threatened by the relentless extraction of sand. In this context, it's crucial to understand the importance of sand, the challenges posed by its unsustainable extraction, and the innovative solutions being developed to address this growing global crisis. From creating sustainable alternatives to sand to implementing stricter regulations on sand mining, there are steps we can take to mitigate this issue. By raising awareness and taking action, we can ensure that sand remains a resource for future generations. Sand, in its simplest definition, is a naturally occurring granular material composed of finely divided rock and mineral particles. It is one of the most ubiquitous materials on Earth, found in deserts, beaches, riverbeds, and even on the ocean floor. The composition of sand can vary greatly, depending on its location and the geological processes that formed it. This diversity in composition and texture makes sand a versatile material with a wide range of applications. However, not all sand is created equal. The characteristics of sand can differ significantly based on its origin, which in turn affects its suitability for various uses. For instance, the grain size, shape, and mineral composition can all influence how sand behaves in different environments and applications. The properties of sand can vary significantly depending on its source and formation process, influencing its suitability for different applications. For example, sand from riverbeds, beaches, and manufactured sources each have unique characteristics that make them more or less suitable for specific tasks. River sand, for example, is often favored for construction purposes due to its angular shape, which provides good interlocking properties in concrete. This interlocking ability enhances the strength and stability of the concrete, making it a preferred choice for building foundations and other structural elements. The constant flow of water in rivers naturally rounds the sand grains, creating a rougher texture that enhances the strength and durability of the final product. This natural process of erosion and sedimentation ensures that river sand is consistently of high quality for construction use. Marine sand, on the other hand, is generally finer and smoother due to the constant wave action in its environment. The continuous movement of water polishes the sand grains, resulting in a texture that is less abrasive and more uniform. While this makes it less ideal for concrete, marine sand finds use in land reclamation projects and beach nourishment programs. These projects often require large quantities of sand to restore eroded coastlines or create new land areas, and the fine texture of marine sand is well suited for these purposes. However, the high salt content in marine sand often necessitates extensive washing before use to prevent corrosion issues in structures. This additional processing step can increase the cost and complexity of using marine sand in construction projects. Manufactured sand, also known as crushed stone sand or M-sand, has emerged as a viable alternative to natural sand in recent years. This type of sand is produced by crushing rocks and larger aggregates into finer particles, offering a more controlled and consistent quality compared to naturally occurring sand. Produced by crushing rocks and larger aggregates into finer particles, manufactured sand offers a more controlled and consistent quality compared to naturally occurring sand. This consistency is particularly important in construction, where uniformity in materials can lead to better performance and durability of the final structure. This control over particle size and shape allows for the production of tailor-made sand products optimized for specific construction needs. For instance, different grades of manufactured sand can be produced to meet the requirements of various construction applications, from fine plastering to coarse concrete work. Understanding the different types of sand and their unique characteristics is essential for ensuring the appropriate use of this valuable resource. By selecting the right type of sand for a given application, builders and engineers can achieve better results and enhance the longevity and performance of their projects. As the demand for sand continues to rise, making informed choices about the source and type of sand used in construction will become increasingly important for both economic and environmental sustainability. Responsible sourcing and use of sand can help mitigate the environmental impact of sand extraction and ensure that this vital resource remains available for future generations. The image of vast deserts with endless dunes often creates a misconception about the abundance of sand and its suitability for construction. While it's true that deserts hold massive quantities of sand, this desert sand is ironically unsuitable for making concrete, the very material that forms the backbone of our cities and infrastructure. The reason lies in the unique formation process of desert sand. Unlike river sand, which is shaped by the tumbling action of flowing water, desert sand is primarily formed by wind erosion. This process creates very fine, smooth and rounded sand grains. While aesthetically pleasing, these smooth grains lack the necessary angularity and roughness required for good interlocking and bonding in concrete. Using desert sand in concrete would result in a weaker, less durable material prone to cracking and crumbling under stress. Imagine building a skyscraper with sandcastles. The structure would simply not be able to withstand its own weight or external forces. This unsuitability of desert sand for construction highlights the importance of understanding the specific properties of sand and their impact on material performance. It also underscores the need to look beyond the sheer quantity of sand and focus on the quality and characteristics that make it a valuable resource for our built environment. The global demand for sand, driven by rapid urbanization and infrastructure development, has placed immense pressure on natural sand resources. As cities expand and new infrastructure projects emerge, the need for sand has skyrocketed, making it one of the most sought-after commodities in the world. This surge in demand has led to extensive sand mining activities across the globe, often with little regard for the environmental consequences. While sand mining might appear to be a relatively benign activity compared to other extractive industries, its environmental consequences are far-reaching and often devastating. The extraction process can lead to the destruction of habitats, loss of biodiversity, and significant alterations to the landscape. These changes can have a ripple effect, impacting not just the immediate area, but also the broader ecosystem. The most common method of sand extraction involves dredging riverbeds, beaches, and coastal areas. This method is favored for its efficiency and the high volume of sand it can produce. However, the environmental toll of dredging is substantial, as it disrupts the natural sediment balance and can lead to severe ecological consequences. This process disrupts delicate ecosystems, leading to a cascade of negative impacts. Aquatic life is particularly vulnerable, as the removal of sand can destroy breeding grounds and habitats. The disturbance of the riverbed or seabed can also release pollutants trapped in the sediment, further harming marine life. The removal of sand from riverbeds alters the natural flow of rivers, increasing erosion and sedimentation downstream. This can lead to the destabilization of riverbanks, making them more prone to collapse and flooding. The increased sedimentation can also smother aquatic plants and animals, reducing biodiversity and altering the natural ecosystem. This can lead to changes in water quality, affecting both aquatic life and human communities that rely on these freshwater sources. Polluted and sediment-laden water can harm fish populations and other aquatic organisms, while also posing health risks to people who depend on these water sources for drinking, cooking, and irrigation. Coastal sand mining poses significant threats to fragile coastal ecosystems. The removal of sand from beaches and coastal areas can lead to the loss of habitats for various marine species, including turtles, birds, and fish. The disruption of these ecosystems can have long-term consequences for biodiversity and the health of the marine environment. The removal of sand from beaches disrupts the natural buffer zone that protects inland areas from storms and erosion, leaving coastlines more vulnerable to the impacts of climate change. Without this natural barrier, coastal communities are at greater risk of flooding, storm surges, and other extreme weather events. The loss of sand also means that beaches, which are vital for tourism and recreation, are eroding at an accelerated rate. Furthermore, sand mining operations often destroy coral reefs, seagrass beds, and other important marine habitats, threatening biodiversity and the livelihoods of coastal communities. Coral reefs and seagrass beds are crucial for maintaining healthy marine ecosystems, providing food and shelter for a wide range of marine species. Their destruction can lead to a decline in fish populations and other marine life, impacting local fisheries and the communities that depend on them. The environmental cost of sand mining extends beyond the immediate extraction sites. The areas surrounding mining sites often suffer from increased pollution, habitat destruction, and other negative impacts. The cumulative effect of these activities can lead to significant environmental degradation over time. The transportation of sand, often over long distances, consumes significant amounts of energy and contributes to air pollution. The heavy machinery and trucks used in sand transport emit large quantities of greenhouse gases, contributing to climate change. Additionally, the dust and particulate matter generated during transport can have serious health implications for nearby communities. Moreover, the illegal and unregulated sand mining industry, driven by high demand and weak enforcement, exacerbates the environmental damage and raises concerns about social justice and human rights violations. Unregulated mining often occurs in ecologically sensitive areas, leading to severe environmental degradation. Local communities frequently suffer from the loss of land, water resources, and livelihoods, sparking protests and conflicts. The lack of oversight also means that